But the first thing that we're going to talk about is basically sketching exponential functions and how to find the domain and the range. Okay, so one thing we have to understand whenever we're talking about sketching exponential function, we need to understand only two things. One, you should be able to remember that exponential function has got what we call horizontal asymptote. Horizontal asymptote, it cuts at y. Y is equal to that number that we're going to be finding. Okay, but sometimes you might be wondering, like, how can you know that this is an exponential? Exponential function is either written as e to the power x, e to the power something, or a number to the power something. That is an exponential. Okay, then whenever you come across log or ln, natural log, this is what we call logarithmic. Logarithm. So this is an exponential function. Now, whenever we want to know how to sketch the exponential function, we need to know only three things, like I've said. The first thing is to know how to find the horizontal asymptote. So the horizontal asymptote is the number that is not attached to the exponential. For example, the first question that we have here, it is f of x is equal to 3x plus 4. The number that is not attached to this is basically 0, so it was plus 0. So therefore the horizontal asymptote in that case is 0. So here the number that is not attached is negative 1. So the horizontal asymptote is negative 1. Here it is this one. Here it is that one. Okay. So now you need to equate the power equal to two things. So you get the power, equate equal to 0, get the power, equate equal to 1. So equate equal to 0 and equate equal to 1. Why are we equating to 0 and 1? Any number to the power 0 is 1. Any number to the power 1 is the number itself. When you do this, solve for x. So now if I shift 4 to go to the other side to be 0 minus 4, therefore x is equal to negative 4. Here it will be x will be equal to 1 minus 4 is negative 3. So I have this x, y. So when x is negative 4 and when x is 3, negative 3, what will be the value of y? Y is equal to 3 raised to the power negative 4 plus 4. That gives me 3 raised to the power 0. Y is equal to 1. So there is 1. Next, y will be equal to 3 raised to the power negative 3 plus 4. Then y will be equal to 3 raised to the power 1. So any number to the power 1 is the number itself. So there I have 3. Once you come up with these coordinates, believe me, this is going to be easy for you to sketch. Now when you do that, come up with a simple sketching. Okay. So now I have, in x I have got negative 3 and negative 4. In y I've got 1 and 3. So I've got 1 and 3. Now the horizontal asymptote, it is cutting at y is equal to 0. Y is equal to 0, it is at this line. I'll put a dotted line to show that that is the horizontal asymptote. Now we can have the coordinate negative 4, 1. Negative 4, 1 is basically here. Then negative 3, 3 is there. We have got two lines, we have got two dots. So the line should start closer from the asymptote, then coming down like that, touching these two lines, going like that. Then you put an R. This is the graph of f of x is equal to 3 raised to the power x plus 4. Now let us talk about the domain and the range. If you look at the domain, we're talking about the x values. Where it is coming from we don't know, and where it is ending, it is just, it keep on going. It will go to keep on going. We don't know where it's going to end. Therefore the domain of any exponential function it is from negative infinity to positive infinity. Done. Okay, what of the range? The range is always restricted, so the range starts with the asymptote going to where the graph is going. So in this case, the graph is going toward positive y-axis. So then, starting from 0, not included because we are not including it, just starting closer from the asymptote, going to positive infinity. So that's what you need to understand. Okay, after doing that, let us go ahead and also look at another question, which is question um, question B. So question B is saying, remember, the goal is to find, the first thing is to find the horizontal asymptote. Horizontal asymptote is the number that is not part of the exponential. In this case, is negative 1. So horizontal asymptote is negative 1. Equate the power of the exponential equal to two things. Equate the power equal to 0 equal to 1. So for x is equal to, if I divide both sides by negative 1, 0, x is equal to negative 1. Now let's find the coordinate. This is x, this is y. When x is 0 and when x is negative 1, but I can start with negative 1. You can start with any anyway. Negative 1, then 0. When x is negative 1, y will be equal to 4 raised to the power negative 1 minus 1. Y is equal to negative 1 times negative 1, so it's 4 raised to the power 1 minus 1. Y is equal to 4 to the power 1. Okay, 4 to the power 1 is what? Is 4. So 4 minus 1 is 3. So this one give me 3. What if we put 0? If we put 0, it's going to be 0 times negative is just 0. So y will be equal to 4 to the power 0 minus 1. Y will be equal to 4 to the power 0 is 1 minus 1, 0. So that becomes 0. After doing this, I can now come up with my graph. My horizontal asymptote is at negative 1. I'll put negative 1 here and cut a line. Once I do that, another thing that I have to do is x is negative 1. So I'll put negative 1 here, then and 0. Another thing in y, we have got 3 and 0. So 0 is here, then I've got 3 here. Let's say negative 1 comma 3 is there. Okay. Then another thing that I have is what? 0 comma 0 is there. What does it tell me? It tells me to say, now these curves, they can even tell you to say, in this case the graph can't start like that because it has to touch two lines. So the graph will start from closer to the asymptote, going this side and touching those two. That is my graph. Now what is the domain? Like I said, the domain of any exponential function is from negative infinity to positive infinity. We don't know where it is ending, we don't know where it started from. Okay? Then the range is always restricted. So the range will always start from the horizontal asymptote. So in this case, since it is starting from the negative 1 all the way to positive infinity, not included. You guys pause the video, try to solve part 3 and compare with the answer that I'm going to find. Okay, so let's go ahead. The power, remember the horizontal asymptote is the number that is not part of the, so 3 is part of the asymptote, it is part of the exponential because it is just in the brackets. Okay, so horizontal asymptote in that case it is negative 3. Equate the power equal to two things. Equate the power equal to 0 equal to 1. Therefore x is 1 and x is negative 1. So when x is negative 1, sorry, x should be 0, the first one. Okay, when x is -1 and when x is 0, what will be the value? Y is equal to 3 open brackets 3 raised to the power, when x is negative, so negative times negative, it will give me 1 minus 3. Y will be equal to 3 to the power 1 is 3. 3 times 3, 9. 9 minus 3 again should be 6. So this gave me 6. Y is equal to 3 open brackets 3 to the power negative 0, which is just basically 0, minus 1. N number to the power 0 is 1. 1 times 3, 3. 3 minus 1, which is outside, that gives me what? So 3 times 1 minus 1, that gives me 2. So I have got 2. After getting my 2 coordinate, I can go ahead and now sketch my graph. So there we go. We can clearly see that we have negative 3. So I'll cut the line. Okay, I'll cut the line. Another thing that I have is -1, 6. So now in x I have -1, in y is 0. So then again in y I have got +2 and 6. So then when I do this, I can now have the my coordinate. So I can clearly see -1, 6 is here, 2, 0 is there. Once again, we can clearly see that the nature of the graph is going to be the same, for the fact that here there is negative, then here there is also negative, and then it is also raised to the power negative. So it will be the same. So this is going to come like this. Starting from the asymptote, touching these two guys, going there. That is the graph. Now, what is the domain? Try to pause the video, find the domain. The domain is from negative infinity to positive infinity. The domain for exponential doesn't change, but the range is restricted. So the range in this case is going to be what? The range in this case is going to be starting from the asymptote, -3 to positive infinity. It is just a coincidence that the range is always going to positive infinity, but there are some cases where the graph is going down, then it has to go to negative infinity. Okay, so I want you guys to try sketching at G and tell me the domain and the range in the comment section. I'll be able to see it and I'm going to respond to it. Okay, so now let us look at another type of exponential which involves e. So even here we can clearly see that it's basically the same. We have got the same nature of the graph. Nothing is going to change. Yeah, so we have the first one, that is so you always, now the horizontal asymptote there, it will still be 0. There is no number that is not embedded to which is after the exponential, like I said. Then after doing this, one thing we should be able to know again is that we are going to equate 2x minus 1 equal to 0, 2x minus 1 equal to 1. So for x, if I shift 1 to go to the other side, I'll do it from here. 2x will be equal to 1 divided by 2 divided by 2, x will be equal to half. That will be the first coordinate. So x will be equal to 1 over 2. Now 2x minus 1 is equal to 1. So 2x will be equal to 1 plus 1. That gives me 2x is equal to 2 divided by 2 divided by 2. x is equal to 1. Let's go ahead and find the values of y. The value of e, I want you to understand one thing. The value of e is approximately 2.7. I don't know if it's 41, but or it's 41 or 14, but just know that it's approximately 2.7 something. So then we'll say y is equal to e raised to the power 2, where there is x we put half, minus 1. Y will be equal to e, 2 times half is 1. So 1 minus 1 is 0. E, any number to the power 0 is 1, so this is 1. Y is equal to e raised to the power 2, where there is x we put 1, minus 1. That gives me 2 minus 1, which is e to the power 1. Any number to the power 1 is the number itself. So you don't have to replace e with 2 point something, no, but you should just keep in your mind that e is approximately 2 point something, 2.7 something. Okay. Now using this, I believe you guys can go ahead and sketch using the previous example that I gave you. Okay. So let's go ahead and now sketch. Okay. Let's go ahead and sketch. So then if I want you just to keep in your mind that e is approximately 2.718. It should be 18, but I know that is 2.71. After 1 I don't know the number, but it should be 8. So just keep in your mind that is 2.7 going that side. Okay, so that one we should know. Another thing that we should be able to know again is the reason why I want you to know the value of e is how you are going to replace the values of y. Which number is bigger between 1 and e? It's basically e. Okay, so then the horizontal asymptote is at 0. I'll cut the line here. So when x is half and when x is 1. So when x is half and when it's 1. So y is 1 and e. Now we are going to have our coordinate half comma 1 is here, 1 comma e is there. Starting closer from the asymptote, touching these lines, going there, you put an arrow because we don't know where the graph is ending. From this we can clearly see that the domain will not change, negative infinity to positive infinity, because we don't know where it is starting from and we don't know where it is ending. It can keep on going. It can keep on going until all the way to East Park here. Okay, but the range is restricted. The range starts from the horizontal asymptote to where the graph is going, starting from 0 all the way to positive infinity. Using this concept, let us go ahead and look at another question. So here I'm going to leave 2 for you. I believe you can sketch this one. Okay, let me sketch this one and this one, then I'm going to leave this one for you. Okay, so we have negative e, the horizontal asymptote in that case is 1. That's the number that is not embedded to the exponential, is 1. So this is equal to 0 and negative x is equal to 1. So therefore x is equal to 0 and x is equal to negative 1. When x is equal to 0 and when x is negative 1, what will be the value of y? Y will be equal to e raised to the power 0, because negative is not going to affect anything. Any number to the power 0 is 1. 1 plus 1, 2. So that gives me 2. E raised to the power, I put negative 1 plus 1, that gives me 1. So we have got y is equal to 1 to the e to the power 1 is e plus 1. So e, you don't know what e, we don't replace e with the number because we're not using a calculator. So I'll say e plus 1. But initially, basically that is 3.71 something. Okay, we leave it like that. Let us go ahead and sketch. In x we have got neg 1 and 0. In y we have got 2. We have got 2 and e plus 1. Then the horizontal asymptote is at 1, so I'll cut the line like that. But to make things simple, I'm going to shift this side so that I extend this part this side like that. Now I can clearly see that I have got 0, 2. 0, 2 is there. I can use a different color. Negative 1 negative 1, e plus 1 is there. Starting from the asymptote, we can clearly see touching these two guys, but the graph has to be neat. But anyway, sketching. So this is the graph. Now what is the domain? The domain is from negative infinity to positive infinity. Like I said, it's not going to change. The range is restricted, starting from the asymptote to positive infinity. Now I'm going to sketch the last part, then you guys go and sketch part 3, send me the answer, and write the domain and the range in the comment section. Now let us look at the last question. So now here, when we want to solve this, we should be able to know that this is an exponential. Again, this is an exponential. So then this one, there is no need of us considering the horizontal asymptote. So we're not going to consider any horizontal asymptote because we don't, it's just exponential. So, and then it is squared again. So at the same time, when it is like this, just equate this equal to two things, 0, 1. You want to find the value of x. X is equal to 0 and x will be equal to, now we have to get the square root here. So x squared 1, so you say plus or minus the square root, this and that will cancel. X is equal to plus or minus 1, meaning that I have got three values when x is negative 1, 0 and 1. Then now let's find the values of y. Okay, so y is equal to e raised to the power x squared minus e. Y is equal to e. X is basically negative 1, but negative 1 squared is 1 minus e. So e minus e is 0. So what I have for negative, it will be the same as for positive. If I plug in plus, it will give me still 1. So e to the power 1 is e. If I plug in 0, any number to the power 0, 0 squared is 0. So any number to the power 0, that becomes e to the power 0, then 1. 1 minus e is just 1 minus e, like that. When we do that, we can go ahead and now look at the graph, the nature of the graph which we are going to have. If we look at this, e minus 1 is approximately, we said e is approximately 7 or 2.718. So then 1 minus e is the same as negative, so it will be here. It's the same as negative, so e minus 1. Then you have got negative 1, we have got 1. If you look at this, negative 1 comma 0 is here, 0 comma 1 minus e is there, 1 comma 0 is there. So the nature of the graph will be going like this. It comes there, it touches these two, then it goes there. So you put the arrows because you do not know where the graph is ending. Okay? So this is the graph, the nature of the graph. Other people will tell you to say, but this is the best graph for this equation. Other people will tell you to say they will assume that this is the horizontal asymptote. So when they do that, negative, it will bring to them like this. So it goes there, it goes there, but the best graph, because both are exponential, is this one. Okay, perfect. That's the graph. So that is it about exponential, sketching exponential functions. I hope you have learned something, and try to explore different type of questions, try to solve them. Yeah.